Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on planning and configuring single area OSPF. Let's go and read our objective for this lab. It says plan and implement and verify OSPF operation over local area network LAN interfaces. So if we take a look at our lab topology, we can see that we're working with 4 routers. We can see that router 1 and router 2 are connected via this serial link. And we also see that router 1 is sharing the 10.0.0.0/24 network with router 3. And we can see that router 2 is sharing the 10.2.0.0/24 network with router 4. And we can also see that router 3 and router 4 are connected via a serial point-to-point link as well. All right. And it says right here in Boson, it says 2 switches, switch 1 and switch 2, one for each LAN segment, are not shown or used in this lab. So we can just kind of imagine that we have a switch right here, and we also have a switch right here. Okay. So let's go ahead and take a look at the commands that we're going to be using for this lab. We have configure terminal, which enters global configuration mode from privilege exec mode. We have enable, which enters privilege exec mode. We have end, which is in exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP address subnet mask. This assigns an IP address and subnet mask to an interface. We have IP OSPF priority number value. This sets the router priority, which helps determine the designated router DR for the network. We have network address wildcard mask area ID. This activates OSPF on the specified network and places the matching interface in the specified area. We have ping IP address. This sends an ICMP echo request to the specified address. We have router OSPF process ID. This enters router configuration mode for an OSPF process. We have show IP interface brief. This displays a brief summary of interface status and configuration. We have show IP OSPF process ID area ID database router. This displays the OSPF link state database. We have show IP OSPF interface type number brief. This displays the OSPF interface information. We have show IP route. This displays the IPv4 routing table. And we have show running config, which displays the active configuration file. Boson also gives us a IP address table for each of the devices where we're able to see the device name, all of the interfaces, the IP addresses on each interface, and also the subnet mask on each interface. So we would definitely refer back to this table as needed. But let's go ahead now and hop into the lab. So we're going to keep our lab topology up here at the top left. We're going to be doing our lab ratings in the top right as normal. And we're going to be doing our device configuration down here at the bottom. Okay. So let's go ahead and read our first lab task. It says task number 1. Verify initial configurations. It says this task involves verifying basic connectivity on all routers. So on number 1, it says verify the IP address and state of each interface on each router. The line and protocol state of each of the configured interfaces on each router should be in the up state. All right. So let's confirm that. We can do that by doing show IP interface brief command on each of the routers. So let's do that on each router. Let's do an enable to go into privilege exec mode, and let's do a show IP interface brief on router 1. And we can see that router 1, its serial 00 interface has an IP address, its status is in the up state, and its protocol is in the up state. Also, we can see that the Fast Ethernet 10 interface has an IP address, and it is also in the up state for protocol and also in the up state for status. And we can confirm these addresses by matching them up with the IP address table. So we can see that the serial 00 and Fast Ethernet 10 addresses match up on router 1, so that looks good. Let's go ahead and move on to router 2. Let's do an enable. Let's do a show IP interface brief. And we can also see on router 2, it has a IP address of 10.1.0.2. Its status is in the upstate and its protocol is in the upstate. And we can confirm that IP address right here in the IP address table that Boson provides. We can also see the Fast Ethernet 1.0 interface has an IP address of 10.2.0.2. Its status in the upstate and its protocol is in the upstate. And we confirm the Fast Ethernet 1.0 IP address as well with the table that Boson provides. Let's go ahead and move on to router 3. All right, let's do an enable. Do a show IP interface brief over here on router 3. We can see that its serial 00 has the same IP address that Boson provides, which is 10.3.0.3. Its status is in the upstate and its protocol is in the upstate. And the Fast Ethernet 1.0, we can see its IP address that matches up with Boson, 10.0.0.3. Status is in the upstate and protocol is in the upstate. Looks good. Lastly, on router 4, let's confirm its information. Let's do an enable. Enable. Let's do a show IP interface brief. Here we go. Its serial 00 IP address, 10.3.0.4. That matches up with Boson's IP address table. Status is up. Protocol is up. Looks good. And lastly, the Fast Ethernet 1.0 has an IP address of 10.2.0.4. We can confirm that is the same with Boson. And its status and protocol are both in the upstate. So that looks good. Alrighty. So number 2, it says from router 1, ping router 2 serial 00 interface, which has an IP address of 10.1.0.2, and router 3's Fast Ethernet 1.0 interface, 10.0.0.3. Both pings should be successful. So on router 1, we're pinging this interface on router 2 and this interface on router 3. So let's go ahead and do that. Let's go to router 1 and let's ping to 10.1.0.2. That ping is successful. As you can see, we have 5 exclamation points. Let's do the same thing to router 3's Fast Ethernet 1.0 interface, which has an IP address of 10.0.0.3. All right, let's try that. And those pings are also successful. As you can see, we have 5 exclamation points. So I'm sorry about that. So those pings were successful. All right, so let's go ahead and move on to number 3. It says from router 4, ping router 2's Fast Ethernet 1.0 interface, which has an IP address of 10.2.0.2, and router 3's serial 00 interface, which has an IP address of 10.3.0.3. And it says both pings should be successful. So from router 4, we're pinging router 2's Fast Ethernet 1.0. We can see they share the same subnet, so that ping should be successful. And we're also pinging router 3's serial 00 interface, which is the point-to-point connection right here to router 3. So that ping should also be successful because they're directly connected. But let's go ahead and confirm that. Let's go to router 4. We're here now. Let's do a ping to 10.2.0.2. That ping is successful, as we can see with the 5 exclamation points. And we can do a ping to 10.3.0.3. And that ping is also successful, as we can see from the 5 exclamation points. All right, perfect. So let's go ahead and move on to task number 2. It says plan for OSPF. It says this task involves planning the OSPF configuration. You will use the commands you list here to implement the OSPF in task 3. So number 1, it says all 4 routers should be members of the backbone area. What is the area ID of the backbone area? Well, as we know, the backbone area has an area ID of 0. Let's confirm what Boson is going to say. And yes, it says all 4 routers should be members of the backbone area, which has an area ID of 0. So perfect. All right, so number 2. It says your configuration should be specific enough so that as additional networks are added to the router, those networks are not automatically advertised. The IP address table on each router should be populated with a specific IP address specific IP subnets in your network. Using the IP addresses table lists the specific networks and masks that should be configured to satisfy this requirement. All right, so we see we have the list of router 1, router 2, and router 3, and router 4. So let me go ahead and pull up my iPad, which I have right here. And we're going to just write out all of the addresses that we need for each router, okay? So let's go ahead and scroll down to our IP address table. And we can see we're going to start on router 1. And we're going to do all of its interfaces that needs to be configured with OSPF. So let's write out right here, router 1. And we need to put 10.1.0.0. And that should be a /24. As we can see from the subnet mask of 255.255.255.0. And we also want to do 10.0.0.0, and that should be a /24. All right, let's move on to router number 2. Router 2. All right, it should have 10.1.0.0. So let's do 10.1.0.0, and that should be a /24. And we also want to do the fast Ethernet 1.0, which is 10.2.0.2. But we want to do a 10.2.0.0 and a /24. All right, let's do router 3. Router 3. Start out with its serial 00 interface. It should be 10.3.0.0/24. And it should also have 10.0.0.0/24. So let's do 10.0.0.0/24. All right. And lastly, we want to do router 4. So let's write out router 4 right here. Router 4. And it should be 10.3.0.0/24. And it should also have 10.2.0.0 for its fast Ethernet 1.0. So let's do 10.2.0.0/24. All right, perfect. Looks good. All right. So now number 3, it says list the network commands necessary to accomplish the configuration requirements in the previous step. You would implement these steps in the following tasks. So we can just kind of I'm going to use this next section over here to actually put the actual command that we're going to put in. So as we know, we need to use the 10.1.0.0. So we want to do a 10.1.0.0. And it's a /24. So we're going to do a wildcard mask of O.0.0.255. All right, that's a /24-bit subnet mask. All right, and we want to do 10.0.0.0 O.0.0.255. All right, for router 2, we want to do a 10.1.0.0 and a O.0.0/255. We want to do a 10.2.0.0 O.0.0.255. All right. We also want to do a 10.3.0.0 and a O.0.0.255. And sorry for my sloppy handwriting. It's hard for me to write like this. I usually write with my iPad on a actual desk, so it's kind of hard to write like this. But all good. I think you guys can kind of understand what I'm writing here. 10.0.0.0 O.0.0.255. And lastly, for router 4, we want to do a 10.3.0.0 0.0.0.255. And lastly, we want to do a 10.2.0.0. That's a 2. Let me kind of backspace because that's kind of sloppy. A little too sloppy. 2.0.0. O.O.O.255. Alrighty. So those are the commands that we're going to input. Looks good. All right, so number 4, it says, right here, it says, in this lab, router 1 and router 2 are better model routers. Give 2 methods to force router 1 and router 2 to be elected as the DR over their respective broadcast networks, and explain why it is important to perform this step prior to starting the OSPF configuration process on any of the routers. So we can configure router 1 and router 2 to have higher loopback interfaces. We can configure the loopback interfaces on router 1 and router 2 to be higher than all of the other routers, which would be router 3 and router 4. We could do that. Or we could configure a priority we could configure a high priority on router 1 and router 2. As we know, the default priority for OSPF is 0, but if we configure a priority, for instance, of any number over 0, then they will automatically become the DR or BDR. Or we could configure router 3 and router 4 with a priority of 0, which means that they will not participate in the OSPF process. So those are some options that we could do for making sure that router 1 and router 2 are the DR. And we should do this before starting the OSPF configuration process, because as we know, once the process starts and the DR and BDR election has occurred, once that happens, the DR and BDR, the only way that this would change is if the DR or BDR fail, and then the BDR, of course, would take over for the DR if the DR failed, and then another BDR election will occur. Or we could restart the OSPF process. That's the only way that the DR and BDR would change once OSPF has been initiated on each of the routers. So let's see what Boson is going to say. It says, there are several methods to force router 1 and router 2 to become the DR for each of their respective broadcast networks. For example, you could do one of the following. It says you could configure each router with a higher loopback IP address interface. You can configure each router with a higher loopback IP interface address, which is one of the things I listed. I also said that you can configure a higher router ID. Well, I didn't say that, but that is another one. I didn't say that, but you can configure a higher router ID than the neighbor routers. Or you can configure a higher OSPF priority on the router. You want the DR for the you can configure a higher OSPF priority on the router you want to become the DR for the broadcast network. And I did mention this one. So the only one I didn't mention was configuring a higher router ID. And that is definitely a great option you could use. So it says, in this lab, you will use a higher OSPF priority that takes precedence over the router ID to cause router 1 and router 2 to become the DR for their respective broadcast networks. All right. So also, it says you could configure router 3 and router 4 with an OSPF priority of 0 to prevent either device from being elected DR. Setting an OSPF priority of 0 on router 3 and router 4 would not only prevent them from becoming the DR, doing so would also prevent them from becoming the backup designated router or BDR, and this is not desired for this lab. So I also explained this as well. You could set the priorities on router 3 and router 4 to have a priority of 0, and if that is the case, they will not participate in the DR and BDR election. And I think at the beginning of this lab, I said that the defaults was 0, but they're actually 1. That was a mistake. I believe I said that, and if I did, I'm going to make that correction right here, right now. Okay? So It says before implementing OSPF on a network, you should always determine the desired precedence for DR and BDR election. Factors such as device speed, age of hardware, and location of the device in relation to the rest of the devices in the broadcast network should be considered because they could affect network performance. Therefore, it is important to perform this step prior to starting the OSPF process on any of the routers. Once the OSPF process is started, it does not elect a new DR unless the DR and BDR fail or the OSPF process is restarted on both devices. If only the DR fails, the BDR will become the DR and a BDR will be elected from the remaining devices in the subnet. And I explained this earlier as well. All right. So that's good information. So number 5, it says, what command could you issue on router 1 and router 2 to configure OSPF priorities in order to satisfy the previous requirement? Well, we could type out, and I'm going to write this down. We could type out IP, OSPF, priority, and then we could just put the priority number of, let's say, 20, if we wanted to configure it to be 20. So let's see what Boson is going to say. It says, yes, you configure IP OSPF priority, and it says 10. So I guess in this lab, we're going to be using a priority of 10. All right. So number 6, it says, what command verifies the interfaces on which OSPF is running? Well, we can do a show IP OSPF interface brief. Well, I spelled that wrong, I believe. Interface brief. All right, let's see what Boson is going to say. And yes, we can do a show IP OSPF brief to verify that the serial 00 and serial fast Ethernet 10 interfaces are running OSPF. All right. On number 7, it says, what command displays the elected DRs, router IDs, interface IP addresses, and priorities? I believe the show IP OSPF interface without the brief will show all this information. So that's what I'm going to go with. I'm going to go with show IP OSPF interface without the brief. Let's see what Boson is going to say. Hopefully that's right. And yes, it says you will issue the show IP OSPF interface command to observe the router ID, interface IP addresses, and priorities. And right here it says, what command verifies that all router adjacencies are up and full? Well, I know this one is show IP OSPF neighbor. OSPF neighbor. All right, let's see what Boson is going to say. And yes, the show IP OSPF neighbor command verifies adjacencies are up and full. All right, perfect. So now we're moving on to task number 3. Let me put my pencil back in my iPad. Perfect. All right, task number 3 says implement OSPF configuration. It says this task involves implementing the configurations planned in task 2 on all 4 routers. So it says each router in an OSPF broadcast network must be uniquely identified by its router ID. Configure a router ID on each router by configuring an IP address on a loopback interface on each router. Issue the command necessary to configure a loopback 0 interface on each router. The IP address of each interface should follow the pattern x.x.x.x, where x is the router number. For example, router 1's loopback 0 IP address would be 1.1.1.1. Use a /24-bit subnet mask as the subnet mask, okay? So let me move my iPad out of the way so we can focus on our each router's loopback 0 interface. That's what it wants us to do. So on router 1, let's do a configure terminal. And let's go into interface for loopback. We want to do a loopback 0 interface. And we want to do an IP address of 1.1.1.1 and 255.255.255.0 for that /24-bit subnet mask. And let's do a do show IP interface brief, just to confirm that that is configured. And it is. We can see loopback 0. We can see its IP address. The status is up and its protocol is up. Let's go ahead and move on to router number 2. Let's do a configure terminal. Let's go into interface for loopback 0. And we want to do an IP address of 2.2.2.2, 255.255.255.0 for that slash 24-bit subnet mask. So let's do a do show IP interface brief. And we can see that it is configured with the correct IP address. Status is up and its protocol is up for the loopback 0 interface. Perfect. Let's move on to router number 3. Configure terminal. Interface loopback 0. IP address 3.3.3.3, 255.255.255.0. And let's do a do show IP interface brief. And we can see the loopback interface is configured on router 3. Lastly, on router 4, let's do a configure terminal. Let's go into interface for loopback 0. Let's do an IP address of 4.4.4.4, 255.255.255.0. All right, let's do a do show IP interface brief. And the loopback 0 interface is configured here with the correct IP address. Its status is up and its protocol is up. Perfect. Now, on number 2, it says configure router 1 and router 2 with a DR election priority of 10 on their connected LAN interfaces. So on router 1, we're here now. Let's do an exit. And if we look at our topology, we can see that only a DR election is going to occur on the fast Ethernet 1.0 interface on router 1, because that is a broadcast network. The serial interface, because it is a point-to-point connection, a designated router would not be elected on that interface. So what we want to do on router 1, we want to go into interface configuration mode for fast Ethernet 1/0. We want to do an IP OSPF priority of 10. All right, let's hit enter there. And let's do the same thing on router 2. Router 2, we want to do it on the fast Ethernet 1.0 as well, because that is the connection down to router 4. And this is a broadcast network because we have the Ethernet connection. So let's do an exit. Let's do interface fast Ethernet 1/0. Let's do an IP OSPF priority of 10. All right. So now on number 3, it says configure each router with a specific network command so that only the serial 00 and fast Ethernet 1.0 interface runs OSPF using OSPF priority ID of 100. So now we can put our iPad back right there so we can just type out each of these networks. So on router 1, let's do an exit. Let's go into router OSPF, and we want to do a process ID of 100. And let's do a network of 10. Excuse me. I think I clicked off 10.1.0.0. Let's do 0.0.0.255 for area 0. Hit enter there. Let's do a network for 10.0.0.0, 0.0.0.255, area 0. Perfect. Let's go to router 2. And we're just doing all of these right here that we already listed out. So let's do an exit. Let's go router OSPF for process ID of 100 here as well. Hit enter. Let's do a network of 10.1.0.0, 0.0.0.255, area 0. Hit enter there. Let's do a network of 10.2.0.0, 10.0.0.0, 0.0.0.255, area 0. Hit enter there. On router 3, let's do an exit. Router OSPF 100, network 10.3.0.0.0.255 area 0. Oh man, didn't mean to do that. Area 0. Perfect. Let's do a network of 10.0.0.0.255 area 0. And lastly, on router 4, let's do an exit router OSPF 100 network 10.3.0.0.0.255 area 0. Let's do a network of 10.2.0.0.0.255 area 0. Perfect. All right, now lastly, we're on task number 4. It says verify OSPF. It says this task involves verifying OSPF on the networks. So it says, without checking the LSA database, answer the following questions. Would the LSA database for each router be similar or different within a single area? So for that question, the LSA database for a single area should be the same. It should be similar. And the next question asks, what LSA type should each router have? Well, if we look at our topology, we can see that we have 4 routers, so we should have 4 type 1 LSAs, which are router LSAs. And we should have 2 network LSAs. And we should have 2 network LSAs because we only have 2 broadcast domains that OSPF is configured in. We can see the 10.0.0.0/24 as a broadcast domain because this is a Ethernet connection. And the 10.2.0.0.0/24 network is a broadcast domain because this is a Ethernet connection. These serial interfaces are point-to-point connections, so they will not be advertised as type 2 LSAs. All right. So number 2 says verify your answers by checking the LSA database. So let's do that on each router. Let's do a end. Do the same thing on router 2. Let's do a end. All right. Router 3, same thing. End. And router 4, lastly, let's type in end. All right. Now, on router 1, let's do a show IP OSPF database. And yes, we can see that we have 4 type 1 type 1 LSAs, as you can see right here. We have 4 of those, and that is each of these routers that we have within our topology. And we can tell that these are each routers by the loopback interfaces that we configured. And we can see that we have 2 type 2 LSAs, and that is the 10.0.0.0/24 network and the 10.2.0.0/24 network. All right, and that should be the same on each of these routers. So if I do a show IP OSPF database, you can see we have the same output here on router 2. Do the same thing on router 3, which have the same output, show IP OSPF database. And yes, we can see everything matches up. Perfect. And lastly, on router 4, let's do a show IP OSPF database. And as we can see, everything matches up here as well on router 4. Perfect. So on router number 3, it says verify that router 1 and router 2 are DRs on their respective broadcast segments. So let's go to router 1. Let's do a show IP OSPF interface. And if we look, let's see. Well, let me actually do this. Let me do a show IP OSPF interface for the fast Ethernet 1.0 so we can kind of cut down some of this output. And yes, this is what we want to see. And if we look, we can see that the state for the fast Ethernet 0.1, it is the DR. If I do the same thing on router 2, let's do a show IP OSPF interface for the fast Ethernet 1.0. We can also see that it is the DR. You can see state DR, so it is the designated router. All right, for its broadcast segment. So lastly, on number 4, it says verify that each router has a route to all 4 routes. Verify that each router has a route to all 4 networks in this area, which is 10.0.0.0, 10.1.0.0, 10.2.0.0, and 10.3.0.0/24 for each of those. So let's do a show IP route. Start on router 2 because we're already here. We can see that we have the 10.0.0, 10.1.0.0, 10.2.0.0, and the 10.3.0.0. So all of those are there. Let's do router 3 next. Let's do a show IP route. Okay, we can see 10.0.0, 10.1.0.0, 10.2.0.0, and the 10.3.0.0. So perfect. Everything is good on router 3. Do the same thing on router 4. Let's do a show IP route. We can see that it has the 10.0.0.0. Can this Grammarly get off my screen, please? We can see that we have the 10.1.0.0, 10.2.0.0, and the 10.3.0.0. Perfect. And lastly, on router 1, let's do a show IP route. And as we can see, it has all of the networks as well, 10.0.0, 10.1.0.0, 10.2.0.0, and 10.3.0.0. So perfect. So that looks to be the end of this lab. So hopefully we did everything correctly. Let's hit grade and see what happens. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.